Hey, good morning. Good morning, guys, and namaste. This is Mr. Golis, and this is one of our first videos, if not the first. I don't really know quite yet because it's I'm speaking to you from a Saturday morning in summertime, just preparing for the school year. So here we go. And I wanted to do the initial lesson on the purpose of physics. And so this is a bunch of slides on the initial lesson. I think it's, this is not really physics yet. This is just an introduction. But don't take that lightly. I mean, this is an important part of your education. All right. A lot of people don't know what the science of physics is or what it does. And if you're going to be an actual educated person, you know things like this. Or what is physics? All right. Whether you like it or not, at the very least, as you know, the next generation of up and coming people and Americans and citizens or whatever the heck, adults, you should know, kind of like, what science does for you, and where it kind of fits into our culture overall, and the civilization that you exist in and that you guys as a generation are going to carry on. Hopefully, you're going to carry it on, and you'll find that I like to talk to you guys that way. You guys are you're the next generation, all right. And my generation will go away. That's the way of things for the human species, and you guys will carry it on, and you guys will, if the pattern keeps going, you'll produce another generation that will eventually replace you, and you're going to want to pass stuff off to them. And my own little part of it is to pass off some knowledge of a specific part of this civilization, which is the science of physics. All right. So let's talk about this. You're in a physics class. What is it? All right. So let me see if I can do this the right way. I haven't made a video since last spring. And so let me just present it. Here we go. And all right. There we go. So, what is physics and what's the purpose of it? Okay. Let me start this way, a little bit of psychology. All right. Science about science in general, and you'll find I'm big into psychology. One of my degrees is in applied psychology, and so even though I teach physics, and my first degree is actually in physics. That's my bachelor's, but I have a master's in applied psychology. So I like to kind of infuse that, is that what we used to think of human beings, all right, and this is why we do science in general. This is why I'm talking about this. Why do we do it? Well, what we used to think of was that human beings were born as a blank slate, meaning that they were born with no knowledge and no instincts at all. We know that that's not true. All right, the psychologist Steven Pinker did research in the 90s and the early 2000s, and he advanced our knowledge on human beings and what we're actually born with. And we know that human beings, like any other animal on the planet, are actually born with instincts. You are born with compulsions to do things. Like a bird is born with the compulsion and the knowledge already in it to build a nest. Nobody has to teach a bird how to build a nest. No one tells a bird to build a nest. Other birds don't raise their younger birds to build nests. It's already there. And you, as a human being, have some instincts that you're born into that actually lead us and compel us to do science. So let's talk about that for a second. This is a nice picture. Here's a little guy. Here's a tiny little human being. All right. And someday when you guys grow up, many of you guys will have someone like this in your life. All right. As you'll be young parents, and you'll have a tiny little human being, and this guy is just playing on a big pile of sand. Why? No one had to tell him to play on the big pile of sand. What happened? He was probably playing around here. It looks like his mom or father put a mat out for him over there, and oh, turned his head, and it's like, well, what's that? It's a big pile of sand. What does it do? What can I do with it? And he just started to climb it, and he's digging in it and all that stuff like that. And that's what human beings, no one had to tell this human child, to do that. Why? Because we know that human beings have an instinct to explore. the environment. All right. In fact, to the point where, if you took a young child, all right, and you just put him on the mat, to play around with stuff, and he or she did nothing, we would probably think something's wrong with that child. It is normal for human children to pick up things and put them in their mouths, and move their little bodies to go climb up things and dig into things like dirt and stuff like that. Nobody has to tell us to do this stuff, and so that's an instinct. All right. So, and what is part of science, is part of the motivation behind human beings doing science, is our instinct to explore and to want to know things about everything around us. Okay. What does this do? What is this tree like? What does this plant do? And we've been doing this for millions of years. Okay. Even before we built cities, when we were out in the forests and the savannas, we picked up plants and we experimented with them. In fact, it's now, through the science of anthropology and archaeology, it's, thought that, like, your average hunter and gatherer, 500,000 years ago would have had, today's equivalent of a PhD degree in forestry, because they knew what plants did what you could eat, when you could eat it, which mushrooms to pick, which ones would kill you, which ones would make you hallucinate, what to put on if you were wounded, what to put on the wound, so that it wouldn't get infected, things like that. Okay, we've been doing this for millions of years. It's born into you, and you're born with the instinct to explore. Okay, so that's part of it. Okay, and here's another one, an instinct that's born into you. We fear, as human beings. We feel afraid. We're scared of things. Okay, we're scared of the unknown. That's a survival instinct. It's an unpleasant feeling, and we try to avoid the feeling of fear. And things that we don't know about make us afraid. That's instinctive. Okay. And so when we do find out about something, it's not as scary anymore. All right. You might find this out. This happens to a lot of parents when you have a child and they experience their first thunderstorm. It's a scary, violent event, and you see these brilliant flashes of light, and you may hear these, loud sounds, and that shake the house and things like that. And your child, will probably, look like this one right here. And I know this certainly happened to me as a parent, and I'm certain that my parents could tell you stories about myself and my brother when we were tiny, when similar things happen. And you try and explain it to the child so it's not scary to them. All right, this is what's going on. It's just a thunderstorm. It's something that happens. It sounds scary, but you're really safe. You're here with me. You're in the house, and it's just a lot of rain and a lot of noise, but it's going to go away. All right. And, that's it's just a natural instinct. All right. So the combination of fear and curiosity, and the motivation to explore, really kind of form the basis for all of our sciences. That's really what science is about. Okay. So here we go. Here's some of the ways that we express these instincts. And you're saying, what are you going? Where are you going with this, Golis? These two instincts and our ability and our desire to manifest, to calm our fears, and to know the world and the universe around us have led us to two great institutions that have been, that are with us. All right. One is religion. All right. You see here a picture of people worshiping. Okay. And the other is science. And they're related to each other, actually. You might not have been taught that, but the reality is, psychologically, they have their roots in the two instincts that I just explained to you. All right. We as human beings, unlike any other animals, we think deeper. We're what's said to be sentient. And what that means is that we know that we are aware of things. And another thing that we know about is that we're going to die. We don't know where our consciousness came from. You can say, well, oh, it comes from the brain. That's really kind of a cop out. That's not very deep, because we really have no idea how the brain makes something that's aware, because the brain is made out of dead matter, right? Protons, neutrons, electrons, atoms, molecules. These things are not alive, but yet, and they're not aware, at least, as far as we know, of anything, but we are, all right? And that's a mystery to us. Why are we aware of things? And, it looks like someday that awareness is going to stop. And if it does, where does it go? Where did it come from? And so, we came up with religions and gods, and this, kind of helps us, all right, to deal with that fear, um, fear of death, wonder about the origins. Where did we come from? Where did the world come from? Where did the universe come from? Science basically takes and puts a method to it, okay, to answer those questions. So, all right, okay, rather than, like, let's tell a story about things, let's actually kind of dig into things. So let's dig into the ground, and, oh, what do we find? We find fossils, and we find, bones of creatures that don't exist anymore. And why is that? And let's come up with a theory as to why these things are here. And we take our telescopes and we point them out into the universe, and we look at stars being born, and we look at galaxies, and we look at stars dying, and, we trace the trajectories back, and we come up with a theory called the Big Bang, which is how we think that the universe started. All right. And so on. All right. So the two things are related. All right. Science and religion. Both, by the way, and, this class is not a discussion for that, but both, by the way, are actually very, very necessary and useful to the human species. All right. Both religion and science together. All right. So anyway, religion, this is what I was surprised that, in my first day as a physics major at St. Bonaventure, in my first physics class, Dr. Budzinski, who had a PhD in physics, actually talked about the lesson that I'm telling you right now. We started off our degrees in physics by learning the difference between religion and science. And this is what I was taught, in my first physics class in college, was that, what religion does is it kind of fills in for us the whys, and science comes up with the hows. And what do I mean by that? Well, science will tell you how the universe started, all right, that according to our numbers and the data, and we do have a lot of evidence for this, that the universe started with an event called the Big Bang, which is very mysterious, all right, where the entire universe, was seemed to literally come out of nothing, out of a single point. But that's, as far as we know, how it happened. All right. Religion comes up with why. Why? Would ask a question like, why did the universe start? That's a different question than how the universe started. Why are we here? As opposed to, how did we come to be here? Those are two different questions. All right. Science doesn't handle the why. All right. That's for religion, and that's, for you to explore. All right. But in this class, we focus obviously on the science, because it's a physics class. All right. In that area of human knowledge. All right. Here's where physics fits in the scheme of sciences. I know there's a lot of, like, different types of names for sciences. There are only three of what are called the physical sciences. Some people will say, well, there's earth science and there's weather science. No, there's really only three basic what are called physical science. That's as opposed to social sciences, which are the study of human beings, the study of human societies, like anthropology, and, the study of human behavior, which is psychology. But of the what are called the hard science, or the natural sciences, there are really only three, and they cover these three areas. And all other sciences, like physical science, earth science, our geology, our applications of these three to a certain cause. Like geology is the application of physics, chemistry, and chemistry mainly, to understand the surface of the earth or the surface of other planets and rock formations and things like that. Okay. Um, but the three basic sciences are biology, which is the study of things that we would say are alive. And that's kind of mysterious, because what does that mean? What does it mean to be alive? All right. Is it just reproduction? Because is a virus alive? I mean, it's just a series of atoms that makes copies of itself. It's a molecule, a DNA molecule that makes. Is it alive? It reproduces, but is it the same as like me being alive that feels and thinks and stuff? Whatever. But it's the study of that. Chemistry, which is basically the study of atoms, okay, and how they go together to form new substances. And both of these sciences are very useful. I don't put my science above any other science or any other area of human academic discipline, not even French literature or something like that. It's just another area of human study, and it's useful. But the other two are useful also. Obviously, the study of life in the past 150 years has extended our lifespan. When my grandfather was born in the year 1916, the average American lifespan was 45. Not that people died, at 45, but it was an average, and it was mainly because you had when you average in, you know. People who die very young versus people who die very old. You had a lot more people dying young back then. Children died in childbirth. It was a common thing. Women died giving birth to children at age, 18 or 20, because women got pregnant earlier back then. It was a different society. That doesn't really happen anymore. Why? Because of the science of biology as applied to medicine or healing human beings. Chemistry gives us all the substances that we use, including all the drugs that we use. These are developed by chemists. They also develop materials. I mean, you're probably watching me on a Chromebook right now. Think of the plastic that makes up the Chromebook. Think of the alloys that go into the solid state chip that is inside your Chromebook. These are developed by chemists. All right. If you took a Chromebook and put it in a time machine and put it back, sent it back 200 years to 1820, they couldn't even reproduce it back then. Even if they understood what the thing was, which they wouldn't, they couldn't even make the plastic to make it, because they didn't even have the knowledge. But we do now. All right. And we keep on accumulating it and building more things and learning more things and making more things. Physics basically covers everything else in the universe. It's kind of the broadest science. It studies the universe in general and how it works. Biology and chemistry, and I'm not criticizing them, they are narrow focused. Biology is narrowly focused on things that are alive. Chemistry is narrowly focused on atoms and how they arrange themselves and can be arranged. Physics studies everything else, from the very large, like cosmology, the universe as a whole, and galaxies and how they're formed and what rules govern them, to the very, very small. It goes lower than atoms to the subatomic realm. What are atoms made of? Oh, protons and neutrons and electrons. Well, what are they made of? Well, they're made of these smaller things called quarks. And what are they like and how do they interact? And so physics basically covers everything else. All right. And physics is the science that gives us our engineering. It allows us to build modern cities with buildings that are, the Burj Khalifa in Dubai is something like, it's about half a mile high or a quarter mile high or something like that. It's, they couldn't do that 300 years ago. They didn't have the knowledge. All right. But we do now. All right. We can build bridges like the Pell Bridge that spans, well over a mile. You couldn't do that in, 1820. They didn't have the physics, to engineer a structure like that, but we can, and we just keep learning more. All right. What physics does, and make sure you have this and understand this, physics explains the universe using mathematics. This was a tradition started by Galileo in about 500 years ago, where he would drop you know cannonballs off the Tower of Pisa to understand that objects fall at the same rate, and he tried to calculate how fast they accelerate and things like that. He used math, all right, and then it was solidified by a man named Isaac Newton. After Galileo, who was very successful at applying mathematics to explaining how the universe worked, and his area was forces in motion. All right. And so he did that, and that's been the tradition ever since, is to write an equation for something. Why? Because equations allow us to predict things. One, you can't contradict math. 2 plus 2 is 4. You can't contradict that. 2 plus 2 was 4 before you were born. 2 plus 2 will be 4 after you're dead. One can even ask the philosophical question, could you ever have a universe where two things added to another two things did not come up with four things, but came up with 3 or 5 or 86? Math is solid. Math is inarguable. All right. And that's why we use it. It's also very useful because an equation can be used to predict things. And I'm going to talk about that a little bit more. Okay. In a minute. There are two types of physics, or here's a relationship between physics and the mathematics and the people who use it. Here are two pictures from the TV show The Big Bang Theory, and here's Sheldon, and Sheldon is a physicist, right? He comes up with equations and he does a lot of math. And then you have Wolowitz, right, who's the engineer in the group, right? And what's the relationship between a physicist and an engineer? Well, a physicist comes up with the equations, then the physicist gives the equations to the engineer, and then the engineer builds things with it. So the physicist will come up with force equations and then give them to the engineer, and the engineer will make a bridge, or the engineer will make a building or a subway system, or the engineer will take the equations and make a vehicle that'll travel at Mach 8, or a vehicle that can leave the Earth and land on Mars. That's the relationship. These guys come up with the equations. These guys use the equations to make things. Okay, and that's the relationship. And here's why we do it. Again, as I was talking about, here's the Burj Khalifa. That's an actual picture of a building that's, you can look it up. I'm going to be conservative and say about a quarter of a mile high. Which, this is in, Dubai, in the United Arab Emirates, and so on. We couldn't do this unless we could predict what was going to happen to it. You just don't tack something like this together. It's not like a frontiersman building a log cabin. You can't just do that, with the Burj Khalifa. You have to predict things precisely, the stresses of metals, the stresses of concrete. You have to know that ahead of time, because if you don't, it's going to fall down and kill everyone. All right. And that's bad, but we can. So we can build things like this. Here is a space shot. This is a SpaceX launch, contracted out by NASA to put a satellite in orbit. And there's an actual photograph of it. That trajectory was predicted ahead of time. We predict it with our equations. You can't just shoot the satellite up there willy-nilly, because it's $1 billion piece of metal. And if it has to be placed precisely in the right place at the right speed, if you don't, it will fall down and burn up and you lost $1 billion. Or if you do it a little too much, it will escape the Earth's atmosphere and you lost $1 billion and somebody is going to get fired. You have to do this with precision. And it's a precision that comes from mathematical equations developed by the science that you're going to be learning this year. Okay, there are two types of physicists, theoretical physicists and experimental physicists. Here is Michio Kaku, out of, I want to say, New York University. He's a theoretical physicist. And basically what these guys do, they're the ones that come up with the equations. All right. And um, so here he is with a chalkboard and stuff. That's actually realistic. If you've ever been to East Hall, is the home of the physics department at URI, and if you've ever been there, yeah, you will see chalkboards or whiteboards, whatever, with equations written on them, on lots of them. And basically, what this guy does is he thinks about things and he writes down equations to explain how the universe works. All right. And it's not just, again, there's a lot of training that goes into this. You have to have a heavy mathematical background. Calculus is the language of physics. In fact, Isaac Newton invented a form of calculus, not the one that we use today. It was invented by someone else, but he invented a form of calculus just to do physics problems. Okay. And then you have the experimenters. All right. And you actually have both to locally tie this in. You actually have both types in this state at the University of Rhode Island. You have your experimentalists who basically work at East Hall and write equations. And then you have the theoreticians who, let me go back to that, who work at East Hall and write down equations. And then you have the experimentalists who actually tend to work at the Bay campus at URI, which has the state's only nuclear reactor on it, which is an experimental building meant to do experiments. All right. And here you see a group of physicists working on a fusion reactor, not a fission reactor, which is how we generate electricity with nuclear power right now. But we want to try and switch methods from fission to fusion, which is much more efficient, much less. There's radioactivity involved, but it's also a bit harder to do. So we're working on that. He comes up with equations. These physicists will test out the equations. If they work, we give them to engineers, and then they make power plants from them. All right. And that's kind of the relationship. And even if you don't go into science, and many of you won't, it's good as an educated person to know things like this. All right. And then that's what having an education means. You know things like this. I have a degree in physics, but I know other things. I know, Shakespeare, and, I know history, and I know things. Why? Because I have a well-rounded what's called a classical education. And hopefully you are aspiring to something like that. And, something deeper than just passing courses. All right. Anyway, here are the branches of physics: mechanics, which is the study of motion and forces. That gives us our civil engineering, building buildings, roads, bridges. Electricity and magnetism, all right, which is, you're going to find out later, are actually the same thing. Electricity is magnetism. Magnetism is electricity. And that gives us our electrical engineering, which is the basis for the communication system that you and I are using right now. Um, um, and so on. All right. And also our whole power grid, which powers the civilization, which we couldn't do without. And would be very bad if it suddenly went away. Nuclear, all right, which is used in medicine, and it for MRI machines, and also chemotherapy and stuff like that, in addition to power generation, which we will probably have to go more and more to. Your generation will probably rely on more and more as we get away from the fossil fuels. Why? Because it's, sun and wind are great, clean, but the sun doesn't shine all the time. The wind doesn't blow all the time. Nuclear is a good fallback to kind of make up, electricity for the times when the sun's not shining or the wind isn't blowing. So, it's used for that. Relativity and cosmology is basically, they look at the universe as a whole. How did the universe get here, and where is it going? Is it ever going to end? And if it does, how? Quantum mechanics looks at the very, very small, subatomics, all right, and so on. And this, I think, branch will become more prominent as the century goes on, because they're trying to make quantum computers, all right, where you store information not on electrical circuits, which gives you a 1 or a 0 for an on or an off, but within the states that you learn of in chemistry of electrons themselves, N1, N2, N3. And we can encode information in the states of electron, which means that you could take like a molecule and actually store information on a single molecule, which means that you could have like supercomputers. They've already created a very primitive quantum computer, and I think they made a couple of them at various universities, and I'm blanking on it. They're in their primitive stages, but everything was in a primitive stage at one point. At one point, computers themselves filled up entire rooms, and now you walk around with the thing in your pocket, which is your phone, and so on. So this will become, I predict this and this will become more prominent for your generation, and I think you guys will probably take them, further, and so on. Killing zombies. Remember that ultimately the goal for all of us is about killing zombies, and except when physicists do it, we do a ray gun like that, because that's who we are, and that's cool. So anyway, make